All right, so this is the last of the methods, elimination method. These ones are going to be the easier ones. Next week we'll get into ones that take a little more work. But real fast, the idea is that at some place you have a positive and negative of the same variable, so that when those are added up, they cancel out, equals 0. So if we add these up, 5x plus negative 3x, you just get 2x. This equals 0. Negative 1 plus negative 3, negative 4. And you can see how fast it is just to get the first coordinate. Again, this is just the third method for doing the exact same problem. So we could graph this. This would be difficult to do with substitution just because there's no easy way to solve for y or x. So it's just another way depending on what problem you're given. So this is still negative 2 for x. You still have to plug it in, back in just like all the others. So you have to plug it back into either one. You'll get the same answer. But if you plug it into the top, okay. Just write this all down so you have it. That's what, 9 divided by negative 3, and there you go. And sometimes you'll end up crossing off x's. You'll have y first. It'll be the other way around. It doesn't matter. But make sure in your answer it's always x comma y, regardless of what order you solve it in. You can always check these, plug it back in. 10 times negative 2 is negative 10. Negative 3 times negative 3 is 9. Negative 10 plus 9 is negative 1. Negative 3 times negative 2 is 6. 3 times negative 3 is negative 9. 6 minus 9 is negative 3. So you know for a fact it's absolutely correct. You don't have to turn in your quiz or test or your final next week. Well, I wonder how I did. Check your answers and you'll know. You don't have to hope I get a good grade to pass. You just check your answers and you'll know. Okay? So same idea. The first step is really fast. The second step is really fast. The third step, when you have to plug it back in, is longer, just like it was with substitution method. Okay. Okay, so let's look at number 3, and I'll let you guys go to it. All right, so number 3, you'll see that negative 4x plus 4x cancels out. That's good. But here's a different thing. The y's cancel out as well. If everything cancels out while you're adding, what is left over? What's left over after you cancel out? 0. And on the other side, what do you have? 0. No variables, which means this is true though. Whenever it's true, it's the other one. Infinite solutions. Okay. Now, on a different problem on this worksheet, it'll come out to be false, like 1 equals 0. That's when it's no solution. If you have something that's not true, that's a no solution. Okay. Yep.
How would you graph it?
Okay, if you graph these two lines, if you look carefully, it's the same exact equation, it's just the negatives are changed. So if you solve both of these for y, they'd both actually be the exact same line. If I added 4x and divided by negative 5, it'd be negative 4x fifths. and 24 would be, let's see here, would be minus 24 over 5. Right? And if you graph this one, it'd come out to the exact same thing. So the reason why it's infinite is because the answer is where they intersect. Well, if they're the two exact same lines, that means they intersect everywhere, which means they intersect an infinite number of times because of the same line. So every time you get infinite, if you graphed it, it means that it's the exact same line. They're one and the same. It's just written different like this, but when you solve it for y, it comes out to be identical. Now, what does a no solution graphically look like? If the solution is where they intersect, how can you have no solution? The lines don't touch, so they're parallel. Yeah, so if you graphed a no solution, you'd just see, oh, they're parallel lines, they don't intersect, therefore no solution. Good. On the back, the only thing different on the back is that they don't add up to 0. Right? So what you do, you see how it's close. They need to add to 0. These add to -8. These add to -12. But if you change the sign, then it works. If you change the sign and it works, that's fine. Just change the sign of everything. So change the sign here, change the sign here. And then, yeah, you get 0. Well, actually, here you go. 0 equals what? -22 plus 20? -2. That's not true. No solution. Which means if we graph these, they'd be a couple parallel lines. So, again, one last time, if the signs are almost, if only thing keeping you from adding to 0 is the sign is off, you can go ahead and change the sign of everything and then add like normal. Okay, that does.
That one's no solution.
That one would be no solution. So, for instance, here, you can see that these don't add to 0, neither do these, but if you change this to a plus 2x, then they would. So just change everything. Both sides. And then it does work out. 5y equals 35, and you can finish it up. So these are the easier ones because it's basically already adding to 0, or you just have to change the sign. Next week we'll look at, well, what happens if this is 3, 2, 4, -5. So there's going to be a little bit more work to do, okay? All right, so tomorrow you want to have the substitution finished and the front and back of this finished by the end of class tomorrow, okay? There will be a Khan Academy assignment as well, so you can see some people, if you're finished already, you can start on that and get that done as well. Okay, that's all I have.